Hey, we're moving on to parabolas. Parabolas will be the last part of conic sections that we go over. We have already talked about circles previously. We went over ellipses and hyperbolas. So last thing that we need to talk about are the parabolas. Okay, so a definition of a parabola is this. So we have F. This is what we're going to call our focus. And we have vertex V. So we do not have a center for a parabola. A parabola has a vertex. It has a focus. And then it has what we call a directrix. A directrix is an actual line and should always be written in the equation of a line. Directrix is always going to be a y equals something or an x equals something depending on which direction it goes. So those are the three main points: focus, vertex, directrix. The definition of a parabola is it is the set of all points that are equal distance between the focus and the vertex and the vertex and the directrix, which means that all of these lengths are equivalent. Here, those two are equal, these two are equal, and so on, all the way around. So that is our definition of a parabola. Okay, so I'm just going to show you the proof of how we come up with the equation for parabolas. So we take the definition of a parabola and saying that these two lines are equal to one another. And then we use our distance formula using the, in this case, it's centered, or its vertex is at 0, 0, and its focus, we'll say, is at a point 0, p. And then there's some point xy on the parabola such that 0p to xy and xy to x negative p, this here, this is our directrix. We're going to write an equation for those two lines and set them equal to each other. So that's what's happened here. Set them equal to each other. They multiplied everything out. X minus x was 0, so that simplified very nicely. Simplify, rewrite, all of that. Clear down here until you get this equation. So this is an equation of a parabola that opens up and whose vertex is at 0, 0. One that would not have a vertex at 0, 0 would be x minus h squared equals 4p times y minus k. So only one thing is squared on this. I want you to notice that. I want you to notice this opens up. So in this case, our y terms are closest to the p value. And those, and they're not squared, that is where it's going to open. If p was negative, it would open down. P is positive, so it opens up. What else can I say? Oh, p. Notice p. P is the distance between the vertex and the focus. So that's also very important to know that this distance right here is the distance of p. Well, in the definition, we said that any point between the focus and the vertex also has an equal distance between the vertex and the directrix. So this down here would also be a value of p. So p is a very important part of figuring out what these equations are. It is going to be the distance between the vertex and the focus and the vertex and the directrix. Okay, so as we just built this equation in the last part, when we talk about p right here, we always talk about, we just really want the absolute value of p. Sometimes it's going to come up positive or negative. What that really means is it open up or down or left or right. That's what the negative, that's all the negative means. When we want to know the distance between the vertex and the focus or the vertex and the directrix, we just need a positive p value and we're just going to use the absolute value of that p. So if this equation right here, we want to look at what's closest to the p. So the y values are closest to the p. That means that this is either going to open up or down. And that depends on the value of p. If p is positive, it's going to open up. If p is negative, it's going to open down. Our vertex is at the point hk, and that's all that we really need to know to be able to work with our equation for a parabola. Now, these, I just wanted you to see all of the different ways that we can write the parabola. Okay, this equation right here is the one we are going to use in this section. Okay, and the MyOpen Math, that's the equation that they use. So we're mostly going to focus on that type of equation. Okay, this here is a good diagram. Here is our vertex and here is our focus. They are a distance of p away. Our vertex to our directrix is a distance of p away. Our directrix always needs to be written in the form of a line. So if this is a parabola that opens up or down, our directrix is going to be in the form of y equals something. Okay, and also this is 2p. This is not something that any questions that you have are related to this. I did go through and look. Usually we talk more about that focal diameter. This is focal radius, but since there's no questions on your homework assignment, I'm going to skip that. We're trying to find ways we can pare down as much as possible this year. So only thing here we need to really worry about is the p values, also our directrix, which way our directrix is, and also making sure that your directrix is written as the equation of a line. Okay, let's go ahead and look at graphing one of these. So first thing that we want to know is, how does it open? Is it going to open up, down, left, or right? Well, the y values are closest to our coefficient here where we're going to find p. And so that means that our equation is going to open in the y direction. So it's either going to be up or down. Now to decide if it's up or down, we need to look at the coefficient and our p value. Our p value here is going to be negative. So that means opening down for this one. Vertex. We can also find the vertex easily. So our vertex is negative 1, 3. We also want to find p. So we know 4p is equal to negative 8. Therefore, p must be equal to negative 2. So what we're really interested in is the absolute value of p. Okay, so let's start with that vertex. So negative 1 and 3. And then we know that it opens down. So our focus, this is our vertex here. Our focus is going to be down. So we're going to go down a distance of p, which is 2. And then our directrix goes in the opposite direction, and it is just a line. Just going to make a dashed line across there for our directrix. Okay, whoops. And then draw in your parabola. Okay, pretty rough sketch, but should give you the idea, how do we find our vertex, our focus, and where does the directrix go. Always make sure that that focus and directrix are opposite sides of each other, and your vertex should always be right in the middle of those 2 points. When we are graphing, that is a really good time to use that 2p value. And so 2p, so that means that at the focus, our line, let's go back and see if we can draw that better. We need to go a distance of 2p to hit our graph from the focus. So 2, 4. That does give us 2 more points to graph. 1, 2, 3, 4. So I guess that is an important part. Maybe I should not have skipped out on. So just saying that our focal diameter, which is the total distance, is 4 times p. Focal radius is 2p. Okay, so that is important to our graph. Okay, that's a little bit better of an image. Okay, now let's look at our equation for a horizontal parabola. So a horizontal parabola is going to have the y term is on the left-hand side. The y term is being squared. On the right-hand side, our x term is over here as closest to our coefficient or our p-value. So it's always this side that we want to focus on, the side closest to the coefficient or the side closest to the p-value. So it is going to be opening in the x direction. So it's going to be opening left or right. These, again, are all of the different views we have here. We know that HK is going to be vertex, and then P is going to be the distance still between that vertex and that focus, and the vertex and the directrix. Okay, all the different ways that we can write these equations. This one down here is the most similar, although we do write what's squared on the left-hand side. So this is the formula that we are going to be using for a horizontal parabola. Okay, same thing for all of the p-values. All of the p-values are still the same. So distance of P between the vertex and the directrix, a distance of P between the vertex and the focus, and then a distance of 2P away from the focus and a point on the parabola. Okay, for this next example, we have the equation y minus 3 squared equals 20 times x minus 9. So we want to find the vertex, the focus, and the directrix for this equation. So again, I'm going to look on this right-hand side, what's closest to the coefficient or the p-value, and that is our x. So that means that this equation is going to be opening in the x direction, meaning it's going to be opening left or right. And then I'm going to look at my coefficient to decide. So since my coefficient is positive, it's going to be opening to the right. The vertex for this, the vertex is 9, 3. We also want to find our focus. So our focus point is going to be a distance of P away from the vertex. Now, since we are opening left to right, and this x term is on the right-hand side, it's going to be our x values that change when we are looking for our directrix and our focus. So let's find P. We know that 4P equals 20, therefore P must equal 5. So that tells me that my focus is going to be 5 units away from 9. Now, since it opens to the right, that means that the focus is also going to be to the right of the vertex. So 9 plus 5 is going to be our focus, which is the point 14, 3. Okay, and then our directrix, remember that our directrix is always an equation. So our directrix is going to be on the left-hand side of our vertex, and our directrix is going to be open, it's going to be running up and down. So it's going to be, this is the format for our equation that we have here. Parabola opens to the right, and so we have a vertex, a focus, whoops, our focus would be about here, and our directrix. Okay, and so this would be a distance of P, and this would be a distance of P. Okay, so we need to go a distance of P to the left, and then this is going to be an x equals equation. So we have x equals 9 minus 5 this time, because we want to go to the left of 9, which would then be x equals 4 as our directrix. And those are the three things that we need to find for that.